American Geodesics Incorporated of Richmond, Virginia offers its Semispheres prefabricated building system. The Semispheres building system transforms conventional building materials in use throughout the world into a superior new building enclosure. The result is a geodesic structure that combines the natural strength of dome architecture with the latest material and engineering advances in foam and concrete technology. The Semispheres building system consists of super-insulated polystyrene foam panels sandwiched between structural layers of C-mix Portland cement plaster. The Semispheres building system is super-insulated, strong, and simple to construct. The Semispheres building system is super-insulated. In fact, there is no more energy-efficient structure available on the market today at any price. With a Semispheres dome, yearly heating and cooling costs can be the same as a one-month bill for many comparably sized existing buildings. The Semispheres building system was awarded a 1988 State of Virginia Energy Award for its superior energy performance in monitored real-life case studies. The Semispheres building system is strong, utilizing the latest material and engineering advances in foam and concrete technology. Snow, wind, and impact loading capabilities can even be modified to meet almost any loading conditions. A Semispheres 25-foot model went through 1988 Hurricane Gilbert's 145-mile-per-hour winds outside Kingston, Jamaica without any damage. The Semispheres building system also simplifies the construction steps so that they can be done by attentive owner-builders and other unskilled labor. The Semispheres prefabricated building system is designed for maximum thermal, material, and structural efficiency and construction simplicity. The elegantly simple Semispheres system consists of three components: a super-insulated foam core shell, C-mix Portland cement plaster, and a weatherproof coating. The heart of the Semispheres system is its prefabricated polystyrene foam panels. Manufactured to exacting tolerances, these lightweight, easy-to-handle panels bond directly together and to a perimeter base to form the super-insulated foam core shell. The 8-inch thick panels have a total thermal resistance, or R value, of 32 plus. Tongue-and-groove edges and a patented joining arrangement make the panels self-supporting as they are constructed all the way from the perimeter base with 3 doorway openings to the top apex. The whole assembly can be done by an experienced crew in as little as 1 day. Expanded polystyrene, EPS for short, is an excellent construction material, impervious to fungus, mildew, and rot, and maintaining long-term dimensional stability even under the most severe conditions. The Semispheres building panels neither use nor emit any ozone-depleting chlorofluorocarbons during manufacture, construction, or use. The interlocking EPS panels also provide a permanent supporting form for the structural coats of C-mix plaster. C-mix concrete plaster, a proprietary blend of Portland cement, sand, and C-mix admixtures and reinforcements, imparts permanent structural integrity to the completed foam core shell. C-mix plaster also provides an adjustable range of impact and fire resistance capabilities. The structural reinforcement embedded in the C-mix plaster coats can be one or more of several different state-of-the-art materials, including woven fiberglass and discontinuous steel fibers. When the woven fiberglass is used, application of the C-mix plaster can be with a small plaster pump or by hand. The fabric is embedded by hand in the wet plaster matrix. When the steel fibers are used, they are mixed with the other C-mix plaster components and sprayed all together with larger wet or dry shotcrete equipment. The C-mix plaster works well with the EPS foam panels. The bond between them is strong, and like EPS, C-mix plaster breathes to allow the passage of moisture vapor so moisture cannot trap in the exterior shell. No special venting mechanism or features are necessary. A weatherproof coating is the third component and completes the Semispheres building system. Formulated in a variety of colors, any of several specified coatings weatherproof and beautify the exterior C-mix plaster. Application is simple by roller or spray. Maintenance is easy and minimal. Why is the Semispheres building system so energy efficient? The super insulation begins with the 8-inch thick foam core panels. These prefabricated panels provide an uninterrupted thermal resistance or R value of 32 plus. The same material in a coffee cup with only 1/8 inch wall allows a person to hold boiling water with bare hands. The Semispheres building system has 64 times more insulation. Moreover, since the insulation is continuous, with no interconnecting framework between the foam core panels, there are few passageways for air infiltration or convection currents. The monolithic Semispheres foam core shell and continuous C-mix plaster coats prevent all unwanted air infiltration, as well as eliminating most heat conduction through the completed building shell. This continuous foam and concrete combination can even be carried below grade to the bottom of the foundation. Finally, the Semispheres building system includes extremely well-placed thermal mass. The interior C-mix plaster has a large capacity to absorb and retain thermal energy. This means that, regardless of outside temperature, the interior comfort levels are slow to change. This combination of high insulation, no infiltration, and well-placed thermal mass works exceptionally well with passive solar designs and natural shading and ventilation. Only the smallest heating and cooling equipment is required. A room-size air conditioner or heat pump, 8 to 10,000 BTUs, or even a small 1,500-watt electric heater will suffice for an entire structure. The smallest wood stove will still be oversized. The Semispheres building system provides exceptional thermal benefits in all climates, which are particularly appreciated in areas of great temperature extremes. What makes the Semispheres building system so strong is advanced engineering strength. Part of the system's unique strength comes from the architectural shape. Eliminating the need for massive, expensive concrete posts and beams, this three-dimensional arch structure requires dramatically less bearing components than a similarly rated conventional building system. The dome shape helps carry the load, deflecting compressive loads into tensile forces. Part of the Semispheres system's unique strength comes from the careful engineering of state-of-the-art concrete materials and reinforcements. C-mix plaster coat thickness and type and amount of C-mix reinforcement can even be varied to meet almost any snow, wind, and seismic loading conditions. The Semispheres building system has proven strength. In a load test monitored by an independent testing laboratory, a 25-foot Semispheres structure was subjected to a 10,000-pound load on the top row of 6 panels for a period of 24 hours. This simulated a 50-pound per square foot live loading condition. The greatest point of deflection was only 0.031 inches, 1/32nd of an inch at the top apex. When the load was removed, this same top point rebounded to 0.007 inch deflection, proving dramatically the load-carrying capability of this dynamically tensile structure. Each C-mix plaster coat cures to form a strong, permanent, three-dimensional membrane. The completed Semispheres building system maximizes both thermal and structural efficiency, complies with articles of the CABO Joint U.S. Building Code regulations, and comes with detailed engineering drawings and instructions. How does the Semispheres building system simplify the construction steps? The top quality prefabricated components interlock and work together in a very simple and easy to understand way. The elegant simplicity begins with the lightweight, easy to carry and handle prefabricated foam core panels. These EPS panels sit on a prefabricated perimeter base. This wood or metal base assembly defines the dome perimeter and the 3 base openings. The perimeter base can be assembled on any level foundation, poured concrete slab, block or poured basement walls, or wood deck. Projecting tongues mate with corresponding grooves of adjacent foam core panels and ensure proper placement of these and all subsequent foam core panels. 2 panels join together to form a triangular face. 5 triangular faces join in a pentagonal arrangement. 6 such pentagons comprise the whole foam core shell. The assembly pattern is simple to learn and follow. Foam core shell assembly is accomplished from several bucks of scaffolding rolling around the interior of the perimeter base. A high-strength construction adhesive supplied as part of the basic package bonds all the panels together and to the perimeter base. Assembly of the foam core shell by an experienced crew can be accomplished in as little as 1 day. C-mix plaster can be applied by a variety of methods and equipment, depending in part on the type of reinforcement material selected. When the fiberglass reinforcement is used, which is the preferred method for most owner-built construction, the locally procured sand and Portland cement are mixed with a special C-mix liquid concrete admixture to form the wet plaster matrix. This C-mix liquid admixture increases the bond strength, plaster strength, and waterproofing of the C-mix plaster. Mixing can be with a plaster mixer, a half-inch drill in a large trash can, or a hoe in a mason's tub, or even on the ground. The wet C-mix plaster is applied with a small plaster pump or by traditional hawk and trowel hand method. Depending on weather conditions, application method, and manpower, a specified area of foam core surface is covered by an approximately 1/8 inch thick layer of wet C-mix plaster. Next, a piece of woven fiberglass fabric is cut and embedded into the wet C-mix plaster. Overlapping fabric sheets ensure a continuously reinforced plaster matrix. Additional C-mix plaster may be applied to completely cover the embedded fabric. The interior C-mix plaster coat is applied first, working from the same scaffolding used to erect the foam core shell or from a framed-up second floor or loft. Once the interior C-mix coat has set, the outside can be walked on while applying C-mix plaster to the top foam core panel row. A simple scaffold system provides access to the remaining exterior foam core surface. On the exterior, a second plaster coat, applied either immediately after embedding the fabric or later, can be finished in a variety of textures and patterns. On the inside, a second, thicker plaster coat may be required for extra fire protection before the final finish coat. Mixing, applying, and finishing C-mix plaster uses plastering techniques which are not difficult to learn. Although it may not always look like it was done by a professional, C-mix plastering may be done by almost anyone in good physical shape who is not afraid of hard work. C-mix plastering may be done by an attentive owner-builder in a piecemeal manner over time, or subcontracted out to a local stucco or swimming pool contractor who can apply the C-mix plaster coats much more rapidly and expertly. When the steel fiber reinforcement is used, thousands of special discontinuous steel fibers are mixed in with the other plaster components and spray applied with standard wet or dry shotcrete equipment to the interior foam core shell surface only. The steel fiber C-mix plaster is applied a minimum of 2 inches thick. An experienced crew can complete the entire structural C-mix layer in a single day. A thin finish coat, patterned and textured however desired, completes the interior C-mix steel fiber plaster system. The exterior foam core shell surface may be covered either with a regular fiberglass reinforced plaster coat or with a special synthetic plaster system. The weatherproof coating can be completed by 1 or 2 people in 1 or 2 days. Application needs only a heavy nap extension roller, step ladder, access to the top exterior panels, and a screen to get the material out of its containers. Maintenance is only a matter of periodic touch-up and occasional recoat. The Semispheres building system offers an array of design options. The 3 perimeter base openings can be framed down to whatever size doors and windows are desired. Skylights and roof windows may be cut into and installed in any number of foam core shell triangular faces. Interior walls and second floor framing are according to standard building practices wherever desired. Electrical, mechanical, and plumbing systems are for the most part run in interior walls, just as in conventional construction. Although the electrical can also be installed easily in the foam core shell. Interior frame detailing can be constructed either with conventional stick frame construction or with exposed post and beam. Interior trim detailing can be according to taste. Wings and dormers, either prefabricated or custom made, can be incorporated in a variety of ways. Multiple structures may be joined directly together or interconnected with prefabricated or custom-built entrances and corridors. Alternatively, Semispheres domes may be incorporated with other architectural styles to expand new or existing space with a dramatic addition. The Semispheres building system comes in a variety of sizes and options. A 25-foot Semispheres model creates a 400 square foot great room with a soaring 16-foot tall cathedral ceiling, or a 600 square foot efficiency with the addition of a 200 square foot loft. The 30-foot Semispheres size can provide 1,000 square feet of total floor space with a full second floor. This is large enough for an open living, dining, kitchen area downstairs and 1 or 2 bedrooms and a full bath upstairs. A full walkout basement level can add a 500 square foot master bedroom suite or a large family entertainment and utility area. A double 30-foot design can have an open living, dining, kitchen, great room dome and a second dome with a master bedroom suite downstairs and 2 bedrooms and a full bath upstairs. Or a 3-dome design can have a living, dining, kitchen, great room in the center dome with a kids wing and master bedroom wing in the other 2. A 36-foot size offers over 1,600 square feet of interior floor space with a full second floor. At present, the Semispheres building system comes in 3 sizes. A 25-foot Semispheres model has 400 square feet of interior floor area. The 30-foot model has 500 square feet of interior floor space, and the 36-foot model has 830 interior first floor square feet. The 25-foot size has a 16-foot tall interior ceiling height. The 30-foot, a 19-foot tall center apex, enough headroom for a full second floor, doubling the usable interior floor space. The 36-foot Semispheres dome has a 23-foot tall interior apex. A straight wall design option, available in any size, is the latest new advance in Semispheres design and engineering. Whatever your building needs and desires, a Semispheres design can satisfy and fulfill them all. Why choose the Semispheres building system? Because it creates one of the most energy-efficient structures available at any price. And the Semispheres prefabricated building system comes at a very affordable price. Because the Semispheres system is engineered to withstand the most violent weather conditions and extremes which Mother Nature can dish out. Because the elegantly simple Semispheres system can be built by attentive owner-builders or rapidly by an experienced contractor. Because the Semispheres building system has a virtually unlimited array of design options and opportunities. What can you do to help complete your own Semispheres building project? You can create your own personal Semispheres design, incorporating as many different size Semisphere structures as you want and need. Extra space can even be left for future additions. Perhaps you can act as general contractor, hopefully saving 10 to 15% profit and overhead, even if you do none of the work yourself. Owner-builder labor can easily erect the Semispheres foam core shell and apply the final weatherproof coating. The C-mix plaster can be applied by a willing, able-bodied homeowner or subcontracted to a local professional plastering contractor. Interior carpentry and other utility components can also be subcontracted to professionals or in some cases be performed by owner-builders with enough experience, skill, or special assistance. Whatever your owner-builder degree of involvement, American Geodesics Incorporated stands committed to ensuring your successful project completion. We offer free design and estimating consultation. We will personally deliver your Semispheres kit components to your Semispheres project job site and offer you free on-site consultation when the kit components are delivered. We will work with you to procure any necessary financing and resolve any special building code issues or requirements. Tell us how we can help you construct your own Semispheres building project. The building system with super energy efficiency, advanced engineering, construction simplicity, low maintenance, limitless design. For more information, contact American Geodesics Incorporated, Richmond, Virginia. The Semispheres building system, elegantly simple, simply elegant. Habitat for the 21st century, available for the owner-builder of today.